Hello, my name is Simon, and I'm here with Dennis and Nikolai. We are half of Group 11, and this short video will briefly explain how this program will detect facial features in a grayscale image using code blocks and open frameworks, and display the results on a colored image with red boxes to indicate the facial features. And for this we will also include the surf method. It should be stressed that this is not a part of our project, even though our project actually is also about facial detection. I'm going to show you how, when I run this file, how it looks with the red boxes in the image. As you can see here, I got a lot of red boxes, maybe a little bit too much, but it's definitely there. This is where the header file is where the different libraries will be defined, and basically this is where the most variables are declared, as you can see in the public here. In the setup, which is also a function, it defines all the variables that will be used there. And there's also another function with setup features. The update will constantly be updated, and this is for instance, the video frames and the scaling of the red boxes. And for the draw function, this is basically where all everything that should be shown visually is executed here. The void key pressed, it checks if the key is pressed, and if in case it is, which in this case we set it to the lowercase n, something should happen. And then here two variables are declared. The first one, three variables, sorry, that's true. We got two integers here and we got a float. The first two are to scale the image, and the second one is the scale of the rectangle which will surround the specific areas, which is like, for in this case, the facial features. The off video grabber enables a live stream from the video camera. And down here with the OFX CV color image, the data type is basically the data type that colors the image. And below here, this is what contains a grayscale image. Further down here we have the matrix matte image, which enables a rotation and just basic movements of the red boxes. And down here we have declared an unsigned integer called current detector, and further there's a vector of the data type string, and then we also have a pointer which points to the vector mentioned above, and lastly we have a new vector of the data type key point, and that's basically it.
Hi, I'm Nikolai, and I'm here to tell you about the test app CPP, more specifically the setup function and the update function. First of all, we include the header file, which was explained by Simon, and let's get started with the setup file. In the header file, we have explained we have given some integers, which we give some values in the setup file. The scalar value is set to 1.0 f because it's a float, and the width, which is the size of the screen, along with the height. And here we set the camera to debug and give it a width and a height, which is the same as the width and the height from the integers. Then we create some, we allocate the image in both color and grayscale luminance, which is grayscale, and then we push it through some different phase detectors, which is actually from the OpenCV file called Features 2D, which is a lot of classes which have some different methods to face detection, to detecting facial features, and this pushback actually just means that we can, by pushing the end button, which was explained by Simon, we will switch between the different methods. We have surf, dynamic surf, blah blah blah, and then we go to the current detector. Also an integer explained in the header file, which we set to 0. Then as the current detector is set as 0, we set the feature detector to be equal the current detector here. And then we set the frame rate to be 60, which is how much work the facial detection have to take into the video. Yeah. Then we have the window shape, which is the red box, which we calculate here, and then the update. We have the camera update, which does what it says. It updates the camera in each frame, and here, if the frame is new, it runs this function, this if sentence. At first, we give the picture some pixels that we can put into the screen. It actually just generates the picture, and then we convert it to U, and convert it then to a grayscale image by the luminance. Yeah, and then thereafter we put it into the matrix. And here we have the key points clear, which clear all the vector, all the whole image when we have passed it. And then the next here sets the new key points and the new image in. And now Dennis will have a talk about the draw function and the key function.
Yes, and I will talk about the test app, Draw. First off, we start by setting the background to black. Next off, we push the matrix, so we get all the information contained in it. Then we scale, and this scaling makes a ununiform box based on the x and y coordinates. Then we offset the color to white, and we draw the camera, the webcam feed that we get from the update function, and it starts up in the left corner. Next up, we start by defining a box with no fill, and the color of this box is going to be red, which is defined here. And then we take our vector called keypoint, of data type keypoint, and iterate it from the beginning. And while we iterate it, we have a while loop running. This while loop, which is here, start out by yet again calling the matrix and get the information that is contained within the matrix, which is the current grayscale image. And then it takes the information from the key points and adds a box to it. First off, it starts by setting its radius about how big the box should be in this line of code, which is a float. Then it sets the location of the box where the key point is in this line of code, and followed by its rotation, how it should turn inside the image. Then it creates the rectangle based on the size of the radius, and then it pops the matrix where it adds all the new data that it has changed since it pushed it, and then it says it plus, which then means it takes the next point in the vector next time. And just to be sure, it then again makes the changes to the matrix following the while loop. Next off, we have another offset color to white, and this adds all the information we got up in the left side of the screen with a lot of strings. The first part here tells you what filter you're running based on it basically tells you what filter you're running, and adds a dash to it, followed by the after the dash is still the first line of text up there. After that dash, it adds how many filters we have in total, and finish it off with a semicolon. And in the last line of text here, we indicate the name of the current filter we are using in the program when it's running, and it is to be located at these coordinates when it is drawn. The next string that is added is how many features it detects during runtime. That basically add this line of text, followed by the amount of key points that it has been able to localize in the image, and this defines where that is drawn in the image, followed by the FPS line, which is this one when you run the program, and that is followed by the frame rate that it is currently working with when the program is running. And yet again, this is where it is drawn in the image, in the window. Then when you press, then we got our last function, which is looking for keep pressed, and every time we hit a lowercase n, we change the filter by adding 1 to it, and it changes the draws in the draw function I just explained with the strings as well. But basically it's just add a new filter and keeps running with that filter. And that's about what we have about our program here and how it functions.